You open your eyes in the morning and the world explodes into being. The sun spills across your walls, painting shadows that dance, illuminating dust that drifts lazily in the air. In that instant, everything you know, every color, every shape, every certainty of reality, is delivered to you on a stream of light. Without it, there is only darkness, only void. We live in the belief that photons, those tiny particles of light, are real, that they are the messengers of existence itself. But what if they aren't? What if light, the very thing we've trusted to reveal the truth, is itself an illusion? What if photons, the supposed quanta of light, are not real entities at all, but convenient shadows in the mathematics of physics? Imagine for a moment the cornerstone of modern science, the bridge between the universe and our eyes, between the cosmos and our instruments, gone. It sounds impossible, it sounds absurd. But the deeper you descend into physics, the stranger the picture becomes. The closer we look at photons, the less real they appear. They behave like particles until they don't. They act like waves until they refuse to. They exist only when we measure them, yet they are everywhere, carrying energy across the universe. And in the deepest equations of modern physics, photons might not exist at all. That is the paradox we face. If photons aren't real, what is light? And if light itself cannot be trusted, what can? We begin, as we always must in the ordinary world, with the story we were told in school, a story that feels safe, a story that feels final. The narrative of atoms, electrons and photons, the neat, almost childlike simplicity of particles pinging about the cosmos, building up the world brick by brick. In that story, photons are the messengers of light, the quanta that carry energy from one place to another, the explanation for how sunlight warms your skin or how a laser cuts through steel. It is a story that reassures us. It tells us the universe is knowable, mechanical, and under control. But the truth is far more dangerous. To even begin to see it, we have to shatter this illusion of simplicity and descend into the history of light itself. For thousands of years, light was a mystery that haunted the minds of philosophers and scientists alike. Was it a wave, like ripples in water? Was it a stream of particles, tiny bullets racing through space? The Greeks argued. Newton declared for particles. Huygens fought for waves. For centuries, humanity swung back and forth between explanations, never satisfied, always uncertain. Then came James Clerk Maxwell, whose equations in the 19th century seemed to end the debate. Light was an electromagnetic wave, he proclaimed, continuous, smooth, infinite, a ripple in invisible fields that stretched across the cosmos. The scientific world sighed in relief. The mystery had been solved. But light is treacherous. In the early 20th century, the puzzle returned. The photoelectric effect, light striking a metal plate and knocking out electrons, revealed something deeply unsettling. If light were only a wave, it could not explain what the experiments showed. The effect demanded something discrete, something particle-like. Enter Albert Einstein, who proposed the radical idea of light quanta, little packets of energy, photons. It was a bold solution, a compromise between the infinite smoothness of waves and the sharp certainty of particles. And for a while, it seemed to work. The world embraced photons as the bridge between two irreconcilable pictures. They explained lasers, solar panels, and the very operation of your phone's camera. They became as real in our minds as atoms, as electrons, as the Earth itself. But here lies the problem. Photons are not like atoms. They cannot be trapped, bottled, or touched. We cannot isolate a photon the way we can isolate an electron or a proton. Photons exist only in motion, only as messengers, and when we look closely, they refuse to behave like anything real at all. They go through two slits at once. They interfere with themselves. They arrive only when we observe them, as though their existence depends on our gaze. And in the equations of quantum field theory, Photons are nothing more than ripples, excitations of an underlying field. Not particles, not waves, but something else entirely, something without form, without substance, something that vanishes if you ask the wrong question. So we are left with the unsettling possibility that photons, the very things we built modern physics upon, might not exist in the way we think. And here, at the dawn of our journey, we face the most important question of all. Do we dare to follow this doubt to its conclusion? Do we dare to question light itself? Because if photons are illusions, then reality is not what it seems. And if reality is not what it seems, then everything, from the stars above to the ground beneath your feet, is a shadow, a mask, a fragile construct waiting to collapse. This is where our story begins. We have lived in the glow of light for too long. Now we must step into the darkness it conceals. The theme has already been whispered to you. If photons are not real, then what is reality? But every story requires a spark, a catalyst that tears the ordinary world apart. For light, that spark came not from the imagination of a philosopher, but from the stubborn results of experiment. At the turn of the 20th century, physics was basking in triumph. Maxwell's equations had united electricity, magnetism, and light into a single framework of elegant waves. It was a time of certainty, of faith in progress. Light was understood, quantified, conquered, or so they thought. Then came a small, simple experiment, shining light on a sheet of metal. It should have been trivial. Classical theory predicted that if you flood a metal plate with enough light, electrons would eventually absorb enough energy from the waves to break free. The brighter the light, the more energy the electrons should carry. Simple. Obvious. But that isn't what happened. No matter how intense the light, if its frequency was below a certain threshold, the electrons refused to budge. A flood of red light did nothing. But even the faintest beam of violet caused electrons to leap away with sharp bursts of energy. The electrons cared nothing for brightness, only for frequency, only for the color of the light itself. This was the photoelectric effect, and it broke the world. Classical wave theory could not explain it. Waves accumulate energy gradually, like ripples lapping at a shore. Yet here, electrons behaved as though they were being struck by discrete bullets of energy. One photon, one kick, no build-up, no waiting. Einstein in 1905 provided the daring explanation. Light came in quanta, packets, photons. Each carried a specific amount of energy proportional to its frequency. Red photons were weak, violet photons strong. The photoelectric effect was not a gradual soaking of waves, but a direct impact of particles. It was the birth of the photon. And yet, even as this explanation won Einstein the Nobel Prize, it opened the door to a nightmare. Because photons solved the photoelectric effect, but they defied everything else we thought we knew. Consider the double-slit experiment. Shine light through two narrow openings, and on the wall beyond you see interference, bright and dark fringes, the signature of a wave. This had been the proof of light's wave-like nature for centuries, but if photons were particles, how could they interfere? Fire photons one at a time, slowly, so they cannot overlap. You would expect two neat bands, each photon choosing a slit, but no. Even single photons build up an interference pattern, as if each one interferes with itself, splitting, spreading, becoming a wave, and then collapsing into a point when detected. This is not behavior we recognize. This is not a particle, nor a wave, nor anything we can picture. This is a ghost. The catalyst had arrived, and with it, the cracks spread through physics. Photons, the supposed solution, had become the source of deeper paradoxes. They were at once waves and particles, yet neither. They could interfere with themselves, yet strike as discrete units. They carried energy, yet defied the categories that made energy comprehensible. And lurking beneath it all was the question that has haunted physics ever since. What exactly is a photon? The debate raged. Some declared photons to be as real as bullets, tangible carriers of light. Others argued they were not things at all, but abstract mathematical conveniences, mere symbols in the equations. The Copenhagen school insisted we abandon the question entirely. Photons were neither real nor unreal, only measurements and outcomes. But that is no answer. That is surrender. The catalyst shattered more than equations. It shattered philosophy itself. Because if photons could not be defined, then reality itself could not be trusted. What we see, what we touch, what we know, all of it rested on light. And light rested on nothing. This is the paradox we inherit. Every technology of the modern world, lasers, solar panels, fiber optics, quantum computers, depends on photons. We live in a civilization built on their assumed reality, and yet the deeper we probe, the less real they appear. Imagine the dread of that realization. The messenger that carries every sunrise, every color, every star in the night sky, dissolving into uncertainty. That was the spark. That was the moment the ordinary world of waves and certainty collapsed. The catalyst of photons fractured the story, and physics would never recover. Now the debate begins in earnest. Do photons truly exist, or have we been chasing shadows? The theme has been stated. The catalyst has struck. The journey into uncertainty begins. The spark has been lit, and the ordinary world has collapsed. No longer can we cling to the comfort of waves alone, nor to the simplicity of particles. The photon, this so-called quantum of light, refuses to fit any category we know. But when faced with such paradox, humanity does what it has always done. It debates, it clings, it argues, and through those arguments, the true scope of the mystery is revealed. In the early 20th century, the scientific community fractured over what photons really were. To some, Einstein's light quanta were salvation. They explained the photoelectric effect, solved a pressing puzzle, and promised to illuminate other mysteries of radiation. These scientists embraced the photon as real, tangible, fundamental. But others resisted. For them, the photon was an act of desperation, a fiction born of necessity, a crude patch on the elegance of Maxwell's waves. They could not accept that light, which so beautifully fit the framework of electromagnetism, would suddenly splinter into particles. Max Planck himself, whose work on blackbody radiation had led directly to the idea of quanta, resisted the notion. For Planck, quantization was a trick, a mathematical convenience, not a statement about the fabric of reality. The photon was, to him, a useful fiction, not a building block. This was the tension. Was the photon a discovery or an invention? The debates raged across Europe. At Solvay conferences, the greatest minds of physics gathered, their discussions echoing like thunder through the halls of science. Einstein, Bohr, Schrödinger, Heisenberg, all argued, each convinced, each uncertain. Einstein clung to photons as real, but he was not satisfied either. He wanted them to be particles, definite and knowable, like tiny bullets of light. But experiments betrayed him. Photons interfered with themselves, spread out like waves, refused to localize until the very instant of detection. They defied the reality he yearned for. Niels Bohr countered with the Copenhagen interpretation. Photons were neither particles nor waves, but phenomena, shadows cast by measurement itself. Don't ask what they are, he warned, only what they do. Physics was not about reality, but about prediction. To ask about photons in themselves was meaningless. But what does it mean when science, the very discipline devoted to uncovering reality, tells us not to ask what is real? The debate spread beyond physics into philosophy. If photons exist only as events, not as entities, then what else in the universe is suspect? Is reality itself a construct of interaction, not substance? Are we chasing ghosts through the dark, mistaking our measurements for truth? the cracks widened. Consider Schrödinger's wave function, which describes the probability of finding a photon here or there, but not its actual existence until it is observed. Is the photon real before measurement, or does it exist only when we look? The debate devolved into paradox. The photon both is and is not, both travels every path and none. A riddle disguised as a particle. Then came quantum field theory, with its elegant mathematics that rendered photons not as particles, but as excitations of the electromagnetic field. In this view, photons are ripples, disturbances in an underlying continuum. They are not objects but events, appearing and vanishing in the fabric of reality like whispers on the wind. For some, this was liberation, the photon finally explained, but for others, it was annihilation. If photons are just excitations, then what is real? The field itself, the ripples, or only the equations that describe them? Even within quantum field theory, debates linger. Photons, according to the mathematics, have no mass, no rest frame, no individuality. They cannot be labeled or tracked in the way electrons can. They are fundamentally unobservable in isolation. If something cannot be observed, cannot be defined, and cannot exist apart from interaction, is it real, or is it simply a language we use to describe phenomena we cannot otherwise explain? The philosophers call this instrumentalism, the view that photons are not things but tools. They exist only in the way that a shadow exists, a projection, not a substance. To adopt this view is to admit that our reality is scaffolded by illusions, that the building blocks of existence are not blocks at all, but abstractions. And yet, the opposing camp refuses to surrender. Realism insists that photons must be real, even if we cannot pin them down. They are the carriers of the electromagnetic force, the mediators of every interaction of charged particles. Without them, stars would not shine, atoms would not bind, life would not exist. To call them unreal is to dissolve the very fabric of physics into mist. So the debate continues, unresolved. And as we listen to it unfold, we find ourselves caught in the middle. We depend on photons every moment of our lives. The warmth of the sun, the flicker of a candle, the glow of a screen, all delivered by photons. They feel real because their effects are undeniable. But when pressed to define them, to isolate them, to declare what they are, we falter. The debate swallows us, and certainty crumbles. Imagine standing at a precipice gazing into an abyss. On one side, photons are real, but their reality is incomprehensible. On the other, they are unreal, but their unreality is undeniable. Both paths lead to paradox, both to doubt, and so we linger on the edge, unsure, afraid, compelled to go further. This is the essence of the debate, not merely scientific, but existential. Are photons real, or are they illusions? And if they are illusions, what does that say about everything else we believe to be true? The photon was meant to be an answer. Instead, it has become a question, one that gnaws at the foundations of reality itself. And as the debates raged, the experiments grew stranger, more daring, more unsettling. Each one carried us deeper into the abyss, peeling away the illusion of certainty, revealing not clarity, but chaos. The debate has not ended, it has only sharpened, and it drives us toward the next stage of our descent, the moment when we leave behind the comfort of argument and step fully into the quantum wilderness. Because photons do not wait for our debates to resolve. They act, they defy, they demand that we follow them wherever they lead. And where they lead, the ground beneath our feet may not survive. We have argued, wrestled, and debated, but debates do not change the nature of reality. At some point, we must step out of philosophy and into experiment. We must leave behind the ordinary world of arguments and cross the threshold into the strange domain of the quantum, where intuition collapses and photons reveal their most disturbing truths. This is the break, the point where the story plunges into the unknown. The double-slit experiment had already hinted at it. Fire photons one at a time and they build an interference pattern, as if each photon somehow travels both paths simultaneously. Block one slit after the fact and the photon knows. Attempt to detect which slit it passes through and the interference disappears, the photon behaving as though it chose a single path. Remove the measurement and the interference returns. Light does not merely travel, it responds to knowledge. This is not the world we thought we lived in, but quantum mechanics takes us deeper. The strange rules that govern photons stretch our minds until they fracture. Consider entanglement. Two photons created together in a single quantum event, their properties linked forever. Measure one, and the other instantly responds no matter the distance. A photon here in your hand can dictate the outcome of a photon across the galaxy. Einstein called this spooky action at a distance. He could not accept it, and yet experiment after experiment confirmed it. Entangled photons behave as though space itself were an illusion, as though distance did not exist. Reality itself bends around their bond. Then there is quantum teleportation, where the state of one photon can be transferred to another, erasing the first in the process. Information itself, carried by photons, leaps across space with eerie precision. The photon is not a traveler, but a shadow moving faster than our comprehension. And what of delayed choice experiments? Here, the decision to measure a photon as a wave or as a particle can be made after it has already passed through the apparatus. In such experiments, the photon appears to retroactively decide what it was, rewriting its own history. It is as if time bends under the weight of observation. This is the world we enter once we break into two. A place where photons do not behave like particles, nor like waves, nor like anything we have ever known. They are not messengers of certainty, but tricksters of ambiguity, entities that seem to exist only in the tension between possibility and reality. In the quantum wilderness, we no longer ask, what is a photon? Instead, we ask, when is a photon? Where is a photon? Does a photon exist before we look? The answers twist and fracture. The photon exists everywhere and nowhere, at every path and at none, until the moment of detection forces it into being. But this moment of detection does not settle the matter. It deepens the paradox. For if photons exist only when measured, then what is the role of the observer? Does our gaze bring them into reality? Does consciousness itself collapse the wave function, birthing photons from the void? Or are photons merely records in a grand quantum ledger, existing only as potential until the universe itself decrees otherwise? The further we descend, the less familiar the ground becomes. The quantum world is not merely strange, it is inverted, upside down. Here, the rules we rely upon in daily life no longer apply. Objects do not have definite properties. Time is not linear, cause and effect blur. The photon becomes the emblem of this chaos, a thing that cannot be said to exist in any ordinary sense, and yet governs everything we know. And the implications stretch beyond experiment. Every technology of the 21st century that depends on photons, lasers, fiber optics, quantum cryptography, works not because photons are understood, but because their strangeness is harnessed. We do not tame them. We ride their paradox. We build our civilization on ghosts. This is the true threshold we have crossed. The photon is no longer the neat solution Einstein offered in 1905. It is no longer the comforting quanta of school textbooks. It is a shapeshifter, a phantom, a ripple in a field that exists only when pressed into being. We have left behind the ordinary world of debates and entered the extraordinary world of shadows. And yet the deeper we go, the more disturbing the questions become. If photons can act as waves and particles depending on how we look, then what is their true nature when we do not? Do they vanish into abstraction, existing only as potential? Or do they live in some deeper realm beyond space and time where our concepts cannot reach? This is the upside-down world of quantum reality. A place where intuition falters, logic twists, and reality itself seems to mock us. The photon is the key, but also the lock. It shows us everything we know and hides what we cannot comprehend. And so we stand at the threshold, staring into the abyss of the quantum, realizing that photons are not simply elusive. They are the shadows of a deeper truth, a truth we may never grasp. But we must follow. Because if photons are not real, then everything built upon them, from the stars in the sky to the light in your eye, must be reconsidered. And if photons are shadows, then what casts them? What hidden reality lies behind the veil? We have broken into two, leaving behind the ordinary world. Now, the true journey begins. Into the heart of the photon's paradox, into the wilderness of quantum mechanics, where the ground shifts beneath us and the truth may be stranger than illusion itself. And as we step further, we must ask, are photons the building blocks of reality? Or the cracks that reveal it is all an illusion? While physicists wrestled with their equations, humanity at large continued to live in the glow of light, as it had since the beginning. And if photons are the shadows of a deeper truth, then perhaps our ancestors sensed that strangeness long before science gave it a name. This is the parallel story, the B story, a thread of myth and meaning that runs alongside the science, revealing what photons mean to us, not just what they are. From the dawn of civilization, light has been our ultimate metaphor. To see is to know, to bring light is to banish ignorance. The ancients worshipped the sun not only because it sustained life, but because it illuminated reality itself. Without light, we stumble in blindness. With it, the world reveals itself. And so light became divine, sacred, the essence of knowledge and truth. In Egypt, Ra rode the solar barge across the sky each day, fighting chaos to bring order to the world. In Greece, Apollo drove his chariot of light, illuminating both body and mind. In India, Surya blazed across the heavens, the visible manifestation of cosmic order. And in nearly every culture, darkness symbolized ignorance, death, or evil, while light was life, wisdom, and hope. But light is not always benevolent. In myth, it blinds as often as it reveals. Prometheus stole fire, light's earthly twin, from the gods, granting it to humanity, and for this he was chained and tormented. Moses gazed upon the burning bush and returned with his face shining so brightly that others could not look at him. To see too much light was to be consumed. It is a theme that echoes across history. Light is knowledge, but knowledge is dangerous. Even in philosophy, light became the measure of truth. Plato's allegory of the cave imagines prisoners who mistake shadows for reality. Only by stepping into the sunlight, into illumination, can they see the truth of existence. Augustine and Aquinas spoke of divine light as the source of reason and faith. Descartes saw light as clarity, the mark of certainty. And yet, beneath this universal metaphor, there is unease. If light is the foundation of truth, what happens if light itself deceives us? If photons are illusions, then the very symbol of knowledge is built on a lie. Our ancestors could not know the physics of photons, but they sensed the paradox. Light gives life and clarity, yet blinds and burns. It is both reality and illusion, gift and curse. In this sense, the B story is not a detour, but a mirror. The human story of light reflects the scientific story of photons. Both reveal and conceal, both sustain and destroy. The 17th century brought science and myth together. Newton, in splitting sunlight with a prism, did more than prove that light contained colors. He revealed light's hidden complexity, a truth concealed in plain sight. To some, this was an act of divine revelation. To others, it was theft, a Promethean assault on the mystery of creation. Once again, light's duality, illumination and danger, revealed itself. The photon inherits this tension. To embrace it as real is to accept paradox. To reject it is to reject the foundation of modern physics. Either way, we are left in the dark. The B story also reminds us of what is at stake. Light is not just a scientific puzzle, it is the medium of our existence. Every painting, every film, every book you read depends on photons striking your eyes. Every photograph, every telescope image of galaxies billions of light years away is delivered to us by photons. They are the messengers of beauty, of knowledge, of the cosmos itself. Without them, we are blind, not only to the world, but to meaning. And so the paradox of photons becomes more than academic. If they are not real, then meaning itself is destabilized. What does it mean to see if the very messengers of sight are illusions? What does it mean to know if the bearer of knowledge dissolves under scrutiny? This parallel story haunts us because it strikes at the heart of our humanity. The scientist in the laboratory wrestles with equations, but the human being stares at the sunset and feels awe. The child lights a candle in the dark and feels safe. The artist paints with light on canvas. The filmmaker sculpts light into story. Our lives are woven with photons, whether they are real or not. And perhaps that is the deeper truth. Even if photons are illusions, their effects are undeniable. The myths, the philosophies, the sciences all converge. Light is both real and unreal, both blessing and curse. It gives us the world, even if it is not what we think. In this way, the B story does not contradict the A story. It enriches it. The physicist's doubt echoes the poet's unease. The equations mirror the myths. Both remind us that reality is stranger, more fragile and more beautiful than we imagine. And just as in every Save the Cat arc, the B story carries a lesson the A story alone cannot provide. It whispers that the stakes are not just scientific, but existential, that if photons are not real, then neither is truth as we know it, and that perhaps the very role of humanity is to live within this paradox, to see and not see, to know and not know, to walk forever in the twilight between light and darkness. But the B story, like all good parallels, is not enough on its own. It casts meaning over the scientific quest, but the quest must continue. The photon still taunts us with its contradictions, still dares us to follow deeper. And so we turn back to the experiments, to the fun and games of quantum mechanics, where photons reveal their strangest tricks. Because if the B story teaches us that light has always been paradox, then the A story shows us that photons embody that paradox with terrifying precision. And together, these stories carry us forward, toward a truth we may not survive. This is the part of the journey where photons show us their tricks, where the universe itself becomes a stage, and light performs with a flair that borders on the absurd. If the earlier beats gave us hints of paradox, here we see the full carnival of quantum strangeness, photons playing games with reality itself. We return to the double-slit experiment, but now with all its layers unfolded. Fire a beam of photons through two narrow slits, and you get the familiar interference pattern, bright and dark bands across a screen. This is the signature of a wave. But dim the light until photons emerge one by one, tiny quanta striking the screen in isolation. You might expect two bands, like bullets passing through two doors. Instead, the interference pattern slowly emerges again, as though each photon interferes with itself, spreading across both slits simultaneously. Here, the photon becomes a conjurer, splitting into possibility, traveling all paths, and collapsing into a single spot when observed. And the trick deepens. Place detectors at the slits to catch which path the photon takes, and the interference disappears. Now you see only two bands. It is as if the photon knows it is being watched. Remove the detectors, and the interference returns. The photon performs for the observer, its behavior defined not by the apparatus alone, but by the very act of inquiry. This is no ordinary trick. It is the unraveling of reality. And yet the games do not stop there. In the delayed choice experiment, photons take the performance to another level. Imagine deciding whether to measure the photon as a particle or a wave after it has already passed through the slits. Logic would insist that the photon's path is already chosen. But experiment shows otherwise. Your decision in the present appears to affect the photon's past. The photon behaves as though it knows retroactively how it will be observed. Cause and effect blur. Time itself bends under the photon's strange rules. Then comes the quantum eraser. Here, photons are marked with which path information, a kind of tag that reveals whether they traveled through slit A or slit B. With this information, interference disappears, the pattern collapsing into ordinary bands. But erase the information, destroy the record of which path the photon took, and the interference pattern returns, even if the erasure happens after the photon has struck the screen. It is as if reality waits, undecided, until we resolve the knowledge, as if the universe itself hesitates before collapsing into truth. These experiments border on the theatrical. Photons act like comedians, like magicians, like ghosts. They refuse to conform, refuse to be pinned down. They play with us, trick us, mock us, and yet, through their games, they reveal the deepest cracks in reality. Consider entanglement, another of the photon's favored performances. Two photons are born together, their properties linked. Separate them across any distance, and the moment you measure one, the other responds instantly. No signal passes between them, no time elapses. It is as if space does not exist, as if photons live in a realm beyond distance. Entangled photons behave as one, no matter how far apart they are torn. This is not metaphor, this is experiment, and it suggests that the photon is not simply a messenger of light, but a messenger of a deeper truth, that reality is non-local, indivisible, woven together in ways our minds can barely conceive. And yet even this spectacle is not the final act. Photons can be coaxed into states where they interfere not only with themselves, but with possibilities that were never realized. In experiments of quantum optics, photons create patterns that seem to defy logic, weaving interference from paths not taken. It is as if the photon carries with it the memory of every possibility, every counterfactual, and plays them out on the canvas of reality. This is the fun and games of quantum mechanics. But the word fun is deceptive. For while these experiments dazzle us, they also terrify. Each one chips away at the solidity of reality, reminding us that photons are not what we think. They are not particles, not waves, not objects in space. They are events, shadows, whispers in the quantum dark. They exist and do not exist. They play games not with our instruments, but with the very fabric of causality. What do we do with such performers? Some physicists shrug, declaring that photons are real only insofar as they produce measurable outcomes. Others insist they must exist in some hidden realm, unseen but fundamental. Still others wonder if photons are not real at all, but phantoms conjured by the mathematics of quantum fields. Each position struggles, each collapses under scrutiny, but the photon continues its games, indifferent to our confusion. Perhaps that is the most unsettling lesson of all. Photons do not care if we understand them. They do not care if we believe in their reality. They behave as they will, revealing just enough to dazzle us, concealing just enough to drive us mad. And in their playful cruelty, they reveal the fragility of human knowledge. Because these games are not trivial, they are the foundation of our civilization. Quantum optics powers lasers, transistors, fiber networks, even the screens upon which you may be watching this very documentary. We depend on photons' strange behavior every day, even if we do not understand it. The world we know is built upon their tricks, but as dazzling as the performance is, the show cannot go on forever. At some point, the curtain must lift, and we must ask the deeper question, what lies behind the stage? Are photons real? Or are they only appearances, shadows of a deeper play we cannot see? For now, though, we linger in the spectacle, captivated and unsettled, watching photons dance on the edge of reality. And as the lights dim, one truth becomes clear. The fun and games are only the beginning. The midpoint looms ahead, and with it a revelation that will strike at the heart of our understanding, a twist that will force us to confront the possibility that photons are not fundamental at all. And when that moment comes, the games will no longer feel like games. They will feel like warnings. We have marveled at the tricks, gasped at the paradoxes, and watched photons perform their games. But in the middle of every story there comes a moment when the curtain is pulled back, when the truth is revealed, or at least what feels like truth. This is the midpoint of our journey, and here the photon's mask begins to slip. For decades, physicists debated whether photons were particles or waves, whether they were real or illusions. The experiments dazzled, but they left us with contradictions, not clarity. Then, in the mid-20th century, a new framework emerged, quantum field theory, and with it, a revelation that changed everything. Quantum field theory does not treat photons as particles in the ordinary sense. Instead, it describes the universe as a vast sea of fields, invisible fabrics stretching across space and time. Every particle we know, electrons, quarks, neutrinos, is not a standalone object, but a ripple in its corresponding field. And photons. They are excitations of the electromagnetic field, tiny disturbances, quanta of energy traded back and forth as charges interact. In this view, photons are not particles at all. They are not things moving through space. They are events, ripples, bookkeeping entries in the grand ledger of reality. At first, this seemed like victory. At last, we could reconcile the paradoxes. No longer were photons required to be both waves and particles. They were something deeper, something subtler, field excitations that could manifest as either depending on how they were measured. The photon was no longer a contradiction. It was a triumph of mathematics, a creature of elegance, its strangeness explained away by the beauty of theory. But every false victory conceals a deeper defeat, because in this new vision, the photon dissolves. It ceases to exist as an entity in itself. It becomes nothing more than an abstraction, a ripple in equations, a symbol of interaction. You cannot isolate a photon. You cannot pin it down. It has no mass, no rest frame, no individuality. It cannot be said to exist in the same sense as an electron or a proton. Even in theory, it appears only in motion, only in exchange. So the photon, once imagined as the particle of light, becomes ghostlier still. It is not a particle, it is not an object. It is the absence of an object, a disturbance in a field we cannot see, a mathematical construct in equations we can barely grasp. And this raises a question more unsettling than any we have faced before. If photons are not real in themselves, if they exist only as excitations, then what is light? What is reality? Is the universe itself built not from particles, but from abstractions, from vibrations of unseen fields? This is the midpoint's revelation. Photons may not exist at all, at least not in the way we once believed. And the implications are devastating. Consider the sun. For all our lives, we have imagined photons streaming outward from its fiery surface, racing across the void for 8 minutes before striking our eyes. But in quantum field theory, no such stream exists. There are no tiny bullets of light traversing space. Instead, the electromagnetic field ripples, and those ripples manifest as interactions, detections, only when they reach us. The photons are not out there traveling. They are events, defined only in the moment of contact. Think of it. The stars you see in the night sky, the galaxies scattered across the heavens, you do not see them as they are. You do not see photons that have crossed the void. You see events created here, in your eyes, ripples of a field manifesting as perception. The photons are not ancient travelers bearing messages from distant pasts. They are conjurations, born in the instant of detection. This is not victory, this is erasure. And yet some embrace it. To them, Quantum field theory is the ultimate clarity, the true framework of reality. In this view, photons are real insofar as they are necessary. They are the mediators of the electromagnetic force, the messengers of quantum electrodynamics, the glue that holds atoms together. Their reality lies not in their substance, but in their function. But others recoil. If photons are mere excitations, then they are not real in any ordinary sense. They are shadows, abstractions, fictions we use to describe interactions. The photon dissolves into mathematics, and reality itself dissolves with it. This is the midpoint, the great reveal that feels like an answer, but is in truth another layer of the abyss. We thought photons were particles. We thought they were waves. Now we are told they are neither. They are excitations of fields, ripples of abstraction, and the cost of this revelation is staggering. Because if photons are not real, then what else is not real? Electrons, quarks, time itself. The edifice of physics trembles, and beneath it yawns a void. At this midpoint, the stakes rise, the story darkens. We are no longer playing with paradoxes. We are staring into the possibility that the building blocks of reality are illusions, that what we call light is not light at all, but shadows on the wall of a deeper reality we cannot see. This is the photon's cruelest trick: to seduce us with clarity, then dissolve into abstraction, to give us a false victory, then reveal it as defeat. And so we stand, halfway through our journey, staring at the wreckage of certainty. Photons, the messengers of light, are not real in any ordinary sense. They are ghosts, ripples, equations. They exist and do not exist. They illuminate the world while dissolving under scrutiny. And the question grows darker still. If photons are illusions, then what is the universe built upon? If the very fabric of light is suspect, what else in reality can be trusted? We are halfway to the end, and the path only grows darker. The photons' games are behind us, but the shadows ahead stretch deeper still. For now, the bad guys, the contradictions, the doubts, the unraveling of reality, begin to close in, tightening the noose, pushing us toward the edge of despair. And the abyss waits. The revelation has come. Photons, we are told, are not particles, not waves, but excitations of the electromagnetic field. A neat answer, a satisfying solution. For a moment it feels like victory. But in every story, victories this clean are false. And here the cracks begin to widen. The bad guys close in. Because quantum field theory, as elegant as it appears, conceals its own horrors. It claims to explain photons as ripples in a field, but when pressed to define those ripples, it falters. A ripple of what, exactly? The field is not a substance, not a medium, not a fabric we can point to. It is mathematics, pure and abstract. The field is not seen, it is inferred. Its excitations, photons, are not objects but disturbances in equations. And so the photon dissolves again into a shadow of a shadow. We ask, what is a photon really? And are given answers that vanish as we grasp them. It is a ripple, it is an excitation, it is an interaction, it is an equation. Each reply pushes us deeper into uncertainty, deeper into the void where reality collapses into symbol. The contradictions grow more severe when we attempt to observe photons directly. Unlike electrons or protons, photons cannot be brought to rest. They have no rest frame. They cannot be captured, isolated, or bottled. They move always at the speed of light, and only in that motion do they exist. They are defined not by being, but by doing, by their role in interactions. When they strike a detector, when they exchange between charged particles, they appear. But between they are shadows. Between they are nothing. This is not the behavior of something real. This is the behavior of an apparition. And worse still, quantum electrodynamics, the branch of physics that uses photons as mediators of the electromagnetic force, relies on calculations that are, in their raw form, infinite. The mathematics explodes, producing nonsensical infinities that must be trimmed, renormalized to match reality. The procedure works brilliantly, producing predictions of breathtaking accuracy. But it feels like a cheat. It feels like papering over cracks with clever tricks. The photon is central to these calculations, and yet it may be nothing more than an artifact of the method, a necessary fiction to make the numbers balance. Physicists do not often admit this, but the photon is a puzzle that refuses to settle. It is indispensable, yet intangible. Ubiquitous, yet ungraspable, real and unreal. And the contradictions keep closing in. Consider the photon's individuality. In theory, photons are indistinguishable, not just similar, not just identical, but indistinguishable to the point of annihilating individuality. There is no such thing as photon A and photon B. There are only photons, a collective without identity. If one disappears and another appears, you cannot say the first has survived. You cannot say it has died. They blur into one another, erasing the very notion of discrete existence. If photons are not individuals, can they be real? The contradictions grow sharper when we ask about energy. A photon carries energy proportional to its frequency. This is the rule. But where precisely is that energy before it is absorbed? If the photon exists only as a ripple in a field, then its energy is spread across possibilities, across probabilities, until the instant of detection. Does the photon have energy, or does energy exist only in the moment we measure it? We cannot say. The bad guys press closer still in the form of rival interpretations. Some argue that photons are not real at all, that they are nothing but a convenient language for describing interactions. Others insist they are real, but only as emergent phenomena, not fundamental, but rising from deeper structures we cannot yet see. String theory whispers that photons may be the vibrations of loops of energy, not particles, not ripples, but resonances of hidden dimensions. Loop quantum gravity suggests they may be artifacts of space itself, woven from the granularity of the cosmos. And then there is the most disturbing possibility of all, that photons are illusions born of our limitations, shadows of a reality we cannot comprehend. That the contradictions are not accidents, but signs that our very framework is broken. That photons are not real because real is the wrong category altogether. The noose tightens, every answer dissolves, every theory, elegant or crude, falters when pressed. And still, the photon burns in the equations, indispensable and yet unreal, a ghost we cannot exorcise. The tension is more than scientific, it is existential. If photons are not real, then what is light? What is vision? What is reality itself? We live in a world illuminated by photons, or so we think. Every sunrise, every star, every flicker of fire depends on their reality. If they are illusions, then so are the stars, so is the sun, so is sight itself. The contradictions become unbearable. Photons are essential yet ungraspable. They explain everything, yet they explain nothing. The equations predict with perfect precision, yet the entities they describe slip through our fingers. And this is the point in the story where despair sets in. The bad guys have closed in. The photon is not resolved, it is dissolved. And the walls of reality begin to crumble. But every descent carries us to the next stage, the lowest point, the darkest hour. And so we ask, what happens when the contradictions overwhelm us completely? What happens when the photon, our guide and messenger, unravels before our eyes? That is where we go next. Into the all-is-lost moment, where the photon vanishes, and with it, the last comfort of certainty. There comes a point in every story where the descent reaches its lowest valley, when the light goes out and the path disappears. For us, that moment is now. Because the photon, once our guide, once the very messenger of reality, slips entirely from our grasp. We have debated, we have argued, we have wrapped it in equations, but the closer we come, the less it exists. This is the all-is-lost moment, the place where even light fails us. Consider what we have learned. Photons are not particles, They are not waves. They are not objects in space. They are ripples in fields we cannot see, disturbances in equations that collapse under scrutiny. They cannot be isolated, cannot be captured, cannot be said to exist in any ordinary sense. They are ghosts. And yet, everything we know depends on them. This is the paradox at its most unbearable. We are told that photons are real because they explain so much. But when we ask what they are, we are told not to ask, that the question itself is meaningless. This is the logic of surrender, not of science. It is an admission that reality, at its foundation, is beyond us. And the implications spread like cracks through glass. If photons are illusions, then what of light itself? What of sight? Every moment of your life you see the world by photons striking your eyes. Every sunrise, every starlit night, every book you read, every face you love, all of it carried by photons. If photons are not real, then your entire life is mediated by ghosts, shadows that vanish when pressed. Worse still, if photons are illusions, then so too is the solidity of matter. Photons are the mediators of the electromagnetic force, the glue that binds electrons to nuclei, that holds atoms together, that gives shape and stability to the material world. If they are not real, then what holds you together? What keeps the chair beneath you solid, the earth beneath your feet firm? If photons dissolve, then so does solidity itself. This is the nightmare of the all is lost beat. Not only do photons vanish, but reality itself vanishes with them. The darkness deepens when we confront the abyss of quantum measurement. If photons exist only when observed, then what does it mean to say they exist at all? Does the universe wait for us to look, conjuring photons from nothing when we open our eyes? Does consciousness itself create light? And if so, what does that say about the billions of years before life appeared? Did photons exist in the void of space, racing from stars to planets that had no eyes to see them? Or did they not exist until the first gaze collapsed them into being? The questions spiral into madness. Some physicists embrace this despair, admitting openly that photons are not real in any fundamental sense. They are useful fictions, placeholders in equations, conveniences for calculation. Nothing more. But if that is true, then modern physics rests on ghosts, and the universe is held together by illusions. Others cling to realism, insisting that photons must exist, even if we cannot define them. But their insistence rings hollow, a desperate grasping at certainty in a world that dissolves beneath them. And still the experiments taunt us. Photons interfere with themselves as if they exist in multiple states at once. They respond to delayed choices as if their past is not fixed until we look. They entangle across galaxies as if distance does not exist. Each experiment drives the knife deeper, each one stripping away another layer of reality. And so we reach the bottom. Photons, once the messengers of light, dissolve into unreality. Reality itself crumbles, and we are left staring into the void. This is the all-is-lost moment, the moment of despair, when the very fabric of existence dissolves. The photon, which we thought was real, which we thought was fundamental, is revealed as an illusion, a shadow, a ghost. And with it goes certainty, solidity, truth. But in every story, the darkest moment is not the end. It is the turning point. It is the place from which transformation begins. For in the depths of despair, a new understanding can emerge. And so, though all is lost, a glimmer remains. Perhaps the photon's unreality is not a failure, but a clue. Perhaps its ghostly nature is not an error, but a revelation. Perhaps photons are unreal because reality itself is stranger than we can comprehend, stranger than particles or waves, stranger than objects or fields. Perhaps the photon dissolves not to destroy truth, but to reveal a deeper truth, one that lies hidden beyond our categories, beyond our grasp. But that is not yet. For now we remain in darkness, bereft of certainty, staring into the abyss of unreality. Photons are gone, light is gone, reality is gone, and we are left with nothing but the question, if photons are not real, then what is? The all-is-lost moment has come, and in the silence that follows, we wait for the faintest glimmer of a new dawn. The photon is gone. The messenger of light, the quanta of certainty, the particle we believed carried truth itself, has dissolved. We stand at the edge of the abyss staring into darkness, and for the first time we feel what it means to live in a universe where even light cannot be trusted. This is the dark night of the soul. It is not a moment of answers, it is a moment of silence, a moment when the foundations crack and we hear the groan of a universe built on shadows. The photon, we thought, was a building block, a piece of reality itself. But if it is not real, then what is left? We look back through human history and the despair deepens. For millennia, light has been our guide, our metaphor for truth. To bring light was to bring clarity. To walk in darkness was to stumble in ignorance. From the torch of Prometheus to the divine illumination of Scripture, light was knowledge, and photons were its secret messengers. But now the messengers dissolve. The torch burns with shadows. The illumination flickers and fades. What does it mean if the very symbol of truth is built on illusion? What does it mean if light itself lies? Everywhere we turn, the photon's absence haunts us. The stars in the night sky, which we thought beamed photons across the void, may not be sending us anything at all. The light we see is not ancient travelers bearing messages from the past. It is events conjured in the present, ripples collapsing into existence only when we look. The stars are not shining upon us. They are shadows cast by equations, born in our eyes, not in the heavens. And the implications cut deeper still. The solidity of matter, the warmth of the sun, the beauty of color, all depend on photons mediating the electromagnetic force. Without them, atoms cannot bind, electrons cannot orbit, chemistry cannot exist. If photons are not real, then matter itself is not real in the way we thought. The world we touch, the world we see, the world we believe in, becomes a mirage. This is despair not only for science, but for existence. And yet perhaps the despair is not new. Perhaps we are only rediscovering a truth our ancestors already sensed, that light is both gift and danger, both clarity and deception. The myths spoke of light that blinded, of truths too brilliant to behold. They warned us that illumination comes at a price. And now, in our laboratories, in our equations, we find that price exacted in full. The more we know of photons, the less real they become. The dark night of the soul is not only about physics, it is about humanity. We are creatures who seek meaning, who hunger for certainty, who need the world to be real. But photons refuse us that comfort. They remind us that reality itself may be ungraspable, that truth may be a shadow forever beyond our reach. And so we sit in the dark, stripped of certainty, asking questions that have no answers. What is it to see if the photons that carry sight are not real? What is it to know if the messengers of knowledge dissolve into illusion? What is it to exist if the very forces that hold us together are mediated by ghosts? The dark night of the soul is not solved by equations, it is endured. It is the moment when humanity faces the void and admits its fragility. When we realize that science, for all its triumphs, cannot rescue us from paradox. When we accept that the universe is stranger than we are able to bear. But in this despair, something stirs. Not yet clarity, not yet resolution, but the faintest sense that the photon's unreality may be a clue, not a curse. That perhaps the problem is not that photons are not real, but that our notion of real is too narrow, that we cling to particles and waves, to objects and substances, when reality itself is woven from something else, something subtler, stranger, more profound. This is the purpose of the dark night, to break us so that we may be remade. to strip us of false certainties so that we may glimpse deeper truths, to dissolve the photon so that we may see the universe not as a machine but as a mystery. For now, though, the despair holds. The photon is gone, light is gone, reality is gone, and we are left with nothing but the weight of doubt, the silence of the void, the crushing realization that the messengers of truth are illusions. This is the dark night of the soul, and it is almost unbearable. But from this darkness a new perspective will emerge. The photon may not be real as we once believed, but perhaps it is real in another sense, a sense that transcends our categories, a sense that reveals not defeat, but transformation. The dawn waits beyond the night, but we must endure the night first. We must sit with the void, with the loss, with the silence, because only then can the photon return, and when it does, it will not return as the particle of light, nor as the wave of electromagnetism, nor as the ripple of a field. It will return as something stranger, something deeper, a messenger not of certainty, but of mystery. For now, though, we linger in the night, waiting, doubting, despairing. And the question echoes: if photons are not real, then what is? From the abyss of doubt, a glimmer emerges. The photon is gone, dissolved into paradox, stripped of certainty. Yet even in its absence, we cannot deny its effects. Light still strikes our eyes, stars still shine, lasers still cut. The world continues to move by the rules photons supposedly obey. Perhaps the problem, then, is not the photon, but us. Perhaps photons are not unreal. Perhaps we have been asking the wrong question all along. This is the moment of return, the break into three. A new act begins. Physics offers a clue. Quantum field theory tells us photons are excitations of the electromagnetic field, not particles, not waves, but ripples in an invisible continuum. At first this felt like erasure, but look again. A ripple may not be a particle, but does that mean it is unreal? When wind ripples across water, the wave is not a thing in itself, yet it is undeniably real. It is an event, a manifestation of energy across a medium. Perhaps photons are the same, real, but in a way that defies our categories. The new perspective deepens when we consider context. A photon cannot be isolated, cannot exist alone. It arises only in interactions, when an atom emits, when a detector absorbs, when a field vibrates. Photons are not objects, they are relationships. They are the currency of interaction, the language by which matter communicates with matter. This is not unreality. This is a different kind of reality, not things, but connections, not objects, but events, not building blocks, but the threads that weave the universe together. Seen this way, the paradoxes lose some of their terror. The double-slit experiment no longer demands that a photon be both particle and wave. It demands only that the photon exists as possibility until it interacts, until it relates, until it collapses into an event. Entanglement is no longer absurd action at a distance, but the natural consequence of photons as relationships, bonds that cannot be broken by space or time. The photon's reality is not in itself, but in the network it sustains. And perhaps this has always been true. From the first myths, light was not seen as substance, but as revelation. It was never about photons. It was about what photons did, to reveal, to connect, to animate. Even in metaphor, photons were relational, not absolute. They existed only in the moment of illumination, in the act of bringing darkness into sight. In this new perspective, photons are both less and more than we thought. Less because they are not particles we can hold, not objects we can isolate. More because they are the very fabric of relation, the pulses of interaction that bind the universe together. They are not ghosts, they are bridges. This is not an answer in the traditional sense. It does not give us photons as things. It gives us photons as processes. It tells us that reality itself is not built of blocks, but of interactions, of events, of relationships that weave a cosmic web. Photons are real, but their reality is not what we imagined. And with this realization, the despair begins to lift. The photon's unreality is no longer a curse. It is an invitation to expand our notion of what it means for something to be real. The break into three carries us forward. We move from despair into transformation. The photon has taught us a lesson not by existing, but by refusing to exist in the way we wanted. It has broken our categories and forced us to glimpse a deeper truth, that the universe is not made of things, but of connections, not of particles, but of patterns, not of certainties, but of mysteries that hold us together, even as they elude us. And so the photon returns, not as the particle of light, nor as the wave of electromagnetism, but as something richer, something stranger. It is the messenger of a deeper reality, one in which existence itself is woven from interaction, not substance. This is the dawn after the night. The despair has not vanished, but it has been reframed. The photon may not be real in the way we once thought, but it is real enough to bind the universe, to illuminate the world, to guide us into a deeper understanding of reality. We emerge from the abyss, changed. The photon, once a ghost, is now a teacher, and its lesson is clear. Reality is not what we thought. It is stranger, subtler, more interconnected than we imagined. But the journey is not over. The finale awaits, where we must bring these threads together, the science, the myth, the philosophy, and face the final question. If photons are real as interactions, as relationships, as events, then what does that mean for us, for reality, for the universe itself? The photon has returned. But it has returned, transformed. And so must we. The photon has broken us. It has stripped away the comfort of particles, dissolved the elegance of waves, and mocked our attempts to pin it down. We have wandered through paradox, endured despair, and glimpsed the void of unreality. But now, in the quiet after the storm, we begin to see differently. The photon has not abandoned us. It has transformed us. This is the finale, the synthesis of all we have learned, and it begins with a simple, radical idea. Photons are not things, but relationships. Look again at the double-slit experiment. We once thought it demanded the photon choose a path, or both, or neither. But perhaps it was never about the photon in itself. Perhaps it was always about the photon in relation to the slits, to the detector, to the act of measurement. The interference pattern is not the behavior of a thing. It is the manifestation of an interaction, an event that exists only in the context of its environment. The photon does not exist alone. It exists only in relation. Consider entanglement. Two photons born together remain linked across space and time. If photons were objects, this would be absurd. But if photons are relationships, then entanglement is not a puzzle, but a revelation. The relationship does not fade with distance because the photon was never an isolated thing to begin with. Its reality is the bond itself. To measure one is to touch the relationship, and the other responds because they were never separate. And so, one by one, the paradoxes dissolve when we shift our perspective. Photons are not unreal. They are not failures. They are not mistakes. They are the universe teaching us that reality is not built from objects, but from interactions, from processes, from patterns of relation. The myths of light begin to resonate anew. Light as revelation, not substance. Illumination as connection, not certainty. The torch of Prometheus, the burning bush, the chariot of Apollo. All were metaphors for light as a bridge between worlds, between ignorance and knowledge, between darkness and sight. Perhaps the ancients sensed what physics now forces us to confront, that light is not a thing but an act, not a particle but a passage, not an object but a bridge. The finale builds as science and myth converge. The photon is not the building block of reality. It is the glue, the connector, the revelation itself. It does not exist in isolation, because existence itself is not isolation. It is relation, it is entanglement, it is interaction. And so we are changed. Where once we sought certainty, we now accept mystery. Where once we demanded particles and waves, we now embrace events and relationships. Where once we saw photons as messengers of truth, we now see them as teachers of humility, reminders that reality is stranger, subtler, and more interconnected than we dared imagine. This is not a neat resolution. It is not a return to the comfort of particles. It is not the triumph of waves. It is a transformation, a synthesis that forces us to expand what we mean by real. Photons are not real in the way a stone is real, nor in the way an electron is real. But they are real enough to bind the universe, to illuminate the world, to connect the stars to our eyes. Their reality is relational, contextual, emergent, and that is enough. The finale ends with reflection. Stand under the night sky, look at the stars. For centuries, we believed their light traveled across the void, carried by tiny messengers called photons. Now we see differently. What you witness is not the arrival of ancient travelers, but the birth of events in your eyes, conjured in the moment, woven from relationships that stretch across space and time. The stars are not sending photons to you. They are entangled with you, bound in the great web of interaction that is the universe itself. And in this realization, awe returns. Not the shallow awe of certainty, but the deeper awe of mystery. The photon is not gone. It has been transformed. And so have we. The synthesis is complete. The A story of science and paradox merges with the B story of myth and meaning. Both reveal the same truth, that light is not substance but revelation, not object but relation, not certainty but mystery. We end where we began, with photons streaming into the eye, illuminating the world. But now we know they are not particles, not waves, not objects. They are events, connections, threads of reality itself, and so we live differently, not with certainty but with humility, not with illusions of control but with awe for the strangeness of existence. The photon has taught us that reality is not what we thought. And that may be the most important truth of all. The finale draws to a close with a lingering question. If photons are not real in the way we imagined, then what else in the universe waits to be transformed by our gaze? The photon has led us this far. It has shattered our illusions and shown us a deeper truth. But the journey does not end here. It continues into the mysteries that lie beyond, into the shadows that light cannot yet reveal. Light. It strikes the retina. It fills the room. It pours across oceans of space from distant stars, arriving as if it were the most ordinary thing in the world. For millennia, this was the certainty humanity clung to. Photons as tiny messengers, traveling faithfully from source to eye, delivering truth. The world was illuminated, and illumination was simple. But now, at the end of this journey, we see differently. What once seemed simple has become unbearably strange. The photon is not a tiny courier racing through the void. It is not a marble of light, nor a wave of pure energy. It is not a thing at all, at least not in the sense we imagined. It is an event, a relationship, a fleeting, contextual manifestation of a universe built not from objects, but from connections. The opening image has become the closing image, but it has been transformed. The light entering your eyes is no longer certainty, it is mystery incarnate. What you see is not the arrival of ancient particles from the stars, but the conjuring of interactions, born anew in every instant of perception. Light exists not as substance, but as relation. The photon is not a traveler, it is a bridge. The implications are staggering. If photons are not real in the way we imagined, what else in our universe is built on illusions of certainty? Are electrons truly objects, or merely excitations of deeper fields? Are atoms solid or mostly void? Is reality itself made of things, or of processes, of events, of interactions that weave us into the cosmos. Here we confront the most haunting possibility, that photons, in refusing to exist as things, are whispering a deeper truth about existence itself. Perhaps reality is not made of what is, but of what happens, not of being, but of becoming, not of permanence, but of relationship. The photon is a reminder that the universe is not a collection of objects, but a dance of connections. And in this final revelation, science and philosophy converge. The photon is not real in the way stones and bones are real, but it is real enough to bind the universe, to illuminate the world, to connect us to the stars. Its reality is relational, contextual, emergent. And that may be truer in the end than any particle could ever be. Stand again beneath the night sky. Look at the light of stars that died millions of years ago. That light is not a messenger racing through the void, carrying truth across the gulfs of space. It is an interaction that comes alive in your gaze, an event conjured at the instant of contact, binding you to the cosmos in ways you can scarcely imagine. The photon has been unmasked, not as a particle, not as a wave, not as an object at all, but as a riddle, a paradox, a teacher. It has shattered our illusions and left us with something stranger, subtler, and more profound. It has taught us humility. It has forced us to expand what we mean by real. And it has left us haunted with the recognition that reality itself may be far stranger than our categories, our theories, or even our imaginations can contain.
We end as we began, with light. But now that light is different, it is no longer certainty, it is mystery. It is not the conclusion of a journey, but the beginning of another.
And so the circle closes. The photon has led us from certainty to despair, from despair to revelation, from revelation to transformation. We began with a simple question: are photons even real? And we end with a more profound one: what does it mean for anything to be real? The photon has not given us an answer. It has given us something more valuable: the humility to keep asking, the courage to embrace mystery, the awe to live in a universe where light itself defies our categories. As the final image fades, the question lingers. Not could photons be real, nor must photons be real, but something deeper. If photons are not what we thought, then what else lies hidden in the shadows of our certainty? And perhaps more haunting still, if reality itself is woven not from things but from connections, then where do we end, and where does the universe begin? The photon refuses to say. It only illuminates, only reveals, only binds. It only teaches us that reality is stranger than we can know, and that, in the end, may be the greatest truth it has to offer. Light has always been our metaphor for truth. We speak of enlightenment, illumination, clarity. To see is to know. Yet in pursuing the photon, the very essence of light itself, we have stumbled into a paradox. The more we examine it, the less certain we become of what it is. The photon sits at the crossroads of science and philosophy, a riddle disguised as a building block. It refuses to obey our categories. When pressed, it vanishes into equations. When measured, it collapses into effects, not substance. It behaves like a wave, yet hits like a particle. It exists only when it interacts, never in isolation. It is, in the end, not a thing at all, but a thread in the web of reality, a pulse of relation that binds the universe together. This is not the story we wanted. We longed for certainty, for atoms of light, for particles we could count and weigh. Instead, we found something stranger, something that eludes our grasp, yet shapes our entire existence. The photon has forced us to confront the possibility that reality itself may not be built from objects, but from interactions. Not from permanence, but from fleeting acts of connection. And here lies the profound implication. If photons are not real in the way we imagined, then perhaps nothing is. Perhaps reality is not a warehouse of things, but a network of relationships, Perhaps what we call matter is not substance but process. Perhaps the universe is not built from blocks but from bridges. This conclusion reverberates through every corner of physics. It reshapes our understanding of quantum mechanics, field theory, and relativity. The photon is central to all three, and in its paradoxes, it reveals the limitations of each. In quantum mechanics, the photon forces us to accept probability, uncertainty, the collapse of the wave function. In relativity, it travels at the speed of light, defying time itself, existing everywhere and nowhere along its path. In field theory, it emerges not as a particle, but as a ripple in an unseen field. In every case, the photon is not an object but a paradox, and yet it works. Our technology, our measurements, our very survival depend on its strange behavior. But beyond physics, the photon challenges philosophy itself. What does it mean for something to be real if it cannot be isolated? What does it mean to exist if existence depends on context, on interaction, on relation? The photon suggests that reality is relational, not absolute, that nothing exists alone, but only in the act of connection. This is more than physics. It is a vision of the universe as a web, not a machine, a tapestry of events, not a collection of parts, a cosmos where light is not substance but revelation, not object but bridge, not certainty but mystery. The photon also forces us to reflect on ourselves. We too seek permanence. We want to be solid, certain, independent. But perhaps we are more like photons than we realize. Perhaps our reality is not in what we are, but in how we connect. Perhaps we are not objects, but events. Not fixed, but relational. Not beings, but becomings. This is a humbling thought, but also a liberating one. To exist as relation is to exist as part of something greater, to be woven into the fabric of the cosmos. The photon reminds us that we are never alone, never isolated, never separate. We are threads in the same tapestry, bound together by interactions that stretch across space and time. And so we return to the question, are photons even real? The answer is not simple, not binary. They are not real in the way we once thought. They are not particles, not waves, not objects. But they are real enough to bind the universe, to illuminate the world, to guide our science, to fuel our imagination. They are real as events, as interactions, as revelations. They are real as reminders that reality itself is stranger, subtler, and more interconnected than we ever imagined. The photon has led us to the edge of knowledge, and beyond that edge, into awe. It has forced us to accept mystery, to live with paradox, to embrace the unknown. And in doing so, it has given us a gift far greater than certainty. It has given us wonder. For in the end, perhaps it does not matter whether photons are real in the way we demand. What matters is that they illuminate, they reveal, they connect, they bind, they teach us humility, they fuel our curiosity, they remind us that the universe is larger than our comprehension. And so, as the final light fades, we are left not with answers, but with questions, not with certainty, but with awe, not with particles, but with paradoxes that point toward deeper truths. Perhaps that is the true reality of photons, not objects, but invitations. Invitations to see beyond, to imagine more, to question everything we thought we knew. Invitations to recognize that reality itself is not fixed, but forever unfolding, forever stranger than we can conceive. The photon endures, not as a particle, not as a wave, not as a certainty, but as a mystery. And in that mystery, it binds us to the stars, to each other, to the universe itself. Light still enters the eye. The world is still illuminated. The stars still shine. But now we know what we see is not the whole story. It is only the beginning. And in that realization, perhaps we find the truest illumination of all. Light still touches the eye. The stars still burn. The world is still revealed in luminous detail. But now we understand. Photons are not simple messengers carrying truth across the void. They are riddles, relationships, fleeting events that bind us to the cosmos in ways we can scarcely imagine. So ask yourself, if even light, the very symbol of truth, is stranger than we ever dreamed, what else in this universe waits in the shadows of our certainty? Perhaps the greatest illumination is not in the answers photons give, but in the mysteries they refuse to surrender. Thank you for joining us on this extraordinary journey through the cosmos here on Frontiers of Infinity. If this glimpse into the unknown has sparked your curiosity, be sure to subscribe and join us each Friday at 7 p.m. Eastern, where we unravel the darkest mysteries of space.